So, hello, Professor. This is the final project for business data analysis, customer segmentation, and credit card data. Our team, Mausam Patel, Yassine, Abhishek, and myself, Charan, is honored to present our findings today. So, our project utilizes clustering, an unsupervised machine learning technique used to uncover latent structures within the unlabeled datasets. As demonstrated in our visual map, clustering is the foundation of meaningful data compression and structure discovery. Our technical goal was to partition data into groups with high similarity while remaining significantly different from others. We focused on the problem of managing high dimensional credit card datasets that are far too complex for manual human oversight. Our strategy allows patterns to emerge organically from the data's inherent features. Coming to literature review, in our literature review, we analyzed the evolution of clustering. We contrasted the k-means gold standard optimized for managing spherical segments with the DBS scan organic approach, while k-means relies on geometric rigidity and DB scan allows for the discovery of irregular shapes based on the point proximity. So this concludes our theoretical foundation. I will now hand over the presentation to Abhishek.
Uh, Now I will talk about the pre-processing pipeline. This is the heart of our stability framework 12. Following Parand 2025, we applied standard scalar to ensure different units like credit limits and transaction counts contributes equally to the model 13. We then use principal component analysis PCA to reduce mathematical noise and ensure the algorithm coverages to a globally optimal partition 14. Uh, Charan, go to slide 6.
Yeah.
Now I will cover technical implementation and cleaning. Our implementation involved processing over 10,127 customer records, which are 15 in number. We performed rigorous data pruning by removing administrative name-based columns to eliminate noise 16. Using the elbow method, we plotted the within cluster sum of squares and identified 1k dollar is equal to 6k as the mathematically ideal number of cluster for this portfolio 17. Now I will hand over the next part to Mosam. He will explain further.
Charan, can you open the Word file, please?
Yeah.
So, uh, these are the steps we have performed for a Python project. So, in first step, we have imported all the required Python files: pandas, numpy, matplotlib, cbarn. Next, please. Then we have loaded the data, and we removed the last two columns as on the data set it says that the last two columns are not required, so we removed and perform the data cleaning. Next, please. So step 3, please. Yeah. So in this is again the data cleaning one, but it's described on the second part. um, Next, please. So in this shape point, we decided to get how many rows and columns we have. So in that we can say that we have 10,127 uh, rows, or you can say customers, and 21 columns for describing each customer. Then in next, please, we check that is there any null values for in columns. As you can see, this in this data there is no null value, so we don't have to remove or add some values on it. Next, please. So in this we have imported some more libraries for a cluster, for k-means, PCA, for pipeline, for pre-processing standard scalar, and that kind of. Next, please. Step 5. So in this one, we perform data standardization using standard scalar, and so that our data can be easily identified and ready for k-means. So in step 6, we perform elbow method to find the k, how many clusters we want. So in this, it shows that I have plotted this a graph over using matplotlib and loops and that kind of. Okay, next please. And in this elbow method, as you can see, can you just show the graph just a second? So in this elbow method, as you can see, uh, just sorry. So yeah, so in this elbow method, as you can
Yeah.
see, the graph is totally curved. It's not a straight line. So if it was a straight line, then we can decide, okay, that this amount of cluster is needed. But it's not a straight line, it's a curved one. So we have chosen 6 as a optimal number, because after that it's showing little bit straight line, so that's why we chose 6. Next please. So in this we have created one pipeline for k-means, for a preprocessor, clustering and k-means, and for also PCA. Next please, scroll down. Yeah, this is the whole pipeline stuff. And then we visualize this whole cluster using PCA. We have choose the data and transform those data into columns and rows, and then we have decide like x for component 1, y for component 2, x and y axis, and then and as you can see, scroll down. Yeah, and this, yeah, then you can see there are like about 6 different type of clusters: red, yellow, blue, purplish, green, and gray, kind of, or you can say brown, sorry. Next please. So then I have provided a label, because the cluster is unlabeled data. So I have provided one label to and created a new column cluster and provided that cluster number, from 0 to 5 to each row, I can say. Next please. So then I have decided to get the details of the customers, uh, like how can you just scroll down a little bit, just showing the graph. Yes. So in this, it shows from each group, in each cluster group, how many customers are there and how many customers have left. So as you can see, in group 2 and group 6, there are many customers that have left. Next please. And then I also get the each customer's account activity, kind of, and also that scale that data, and scroll down. And then plot those data into each group, their total transaction amount, and divide each data into their 6 different groups: transaction amount, activities, uh, how many how much times they are on each from this connected to this credit card companies. And yeah, and based on that, scroll down please. Yeah, can you open the PPT?
Yeah.
Next one. These are two elbow method and clustering the screenshot. So on based on that, we have decided like 6 clusters. So on cluster 1, we finding like high value loyalist. They are high limit, and they also spend a y, spend like very high, and we can I decided to give them some rewards like VIP customers and things like that. Cluster 2, as you have remember, all the customers are most of the customers have left on this particular cluster. So I have decided to put it on at risk, and they have high spend but low logins. And so for that, I would suggest a retention strategy. We should try to retain those customers. Cluster 3, they are mostly inactivity. Most of the customers are not active, so try to re-engage them using different methodologies or reactivation. And cluster 4 are credit dependent, high revolving balance with suggestion is interest review revenue, and 5 emerging spenders, increasing transactions, and for credit growth. Cluster 6 conservative holders, they are like they have high tenure but low usage, so they are kind of not active as other customers, so we can provide some incentives to get them activate again. Next please. So my friend Yasin will start now.
Yeah, thank you. So based on our six customer segments, here are the key strategies we recommend. First, we move away from one size fits all marketing of cluster one, our high value loyalists, and cluster five, the emerging spenders should receive tiered rewards and personalized offers. Second, cluster two, the at-risk group, acts as an early churn signal. When customers show that behavior, the retention team should reach out proactively. And third, cluster three, the inactives need low effort reactivation campaigns to avoid wasting marketing spend. And finally, we optimize credit limits by increasing limits for cluster one while watching the high revolving balance behavior in cluster four to manage the risk. Next slide. So for the conclusion, our project shows how unsupervised machine learning can turn complex financial data into real business intelligence using stability first framework and by applying standardization and PCA. We identify six meaningful customer segments, and these clusters reflect real behavior patterns, and they give the bank a clear roadmap for personalized marketing, churn prevention, and strategic revenue growth. Next. Uh, so this slide is a quick visual summary of our workflow. We start with the data science pyramid first, move into the literature review, then follow the pre-processing pipeline using standardization and PCA. From there, we implemented the key means model, identified six clusters, and finally developed business level recommendations based on those savings. Next. Yeah, these are the main academic sources and framework that guide our project, including the Core 2025 Stability Framework and the foundation papers on key means, DB scan, and PCA. Thank you.
Thank you, Professor, for listening to
So,
us.
on myself, we would like to offer our final thanks to Professor Kourosh Parand, and we hope this presentation demonstrated our commitment and the strategic business analysis. Thank you for your time and mentorship throughout the semester. So this concludes our recording. Thank you so much.
Thank you.
Thank you.